So that is on the Zoom side. So even if this breaks, that is kind of backup. Okay, let's not worry about that. Yeah, others, please mute. Okay, let me just mute others. Already muted them. All right, good. So good that you reminded me. So okay, so good. We will start now. Just give me a second. So far, we have discussed about the right. So how to connect to various data sets or various or diverse source systems using Power BI desktop, and also how to perform data transformation, like how to do pivoting, unpivoting, how to do cleaning, data cleaning, and how to do group by. All those things we have seen it, and also we have seen how to use query parameters and so on. In today's session, we will take a look at what is data modeling is all about, and what is relationship, how to define or create a relationship between tables. So, all right, so now let us get started with these topics. What is data model and why data model is required? So what is a data model? So college time, you would have studied, right? So those of you having the computer science background, you must be knowing what is a data model. Okay, in the interest of everyone, right? So data model is like a blueprint. So the data architect, right? They used to convert all the data involved in business process into database. Okay, it is like a blueprint, like an architect's blueprint. Without blueprint, if you construct a house, what is going to happen? Let's say without blueprint, you constructed a house. Your house is in the second floor of the house, in the apartment, okay, second floor, or your house is in the fourth floor, okay. And you, without blueprint, you constructed a house. Later point in time, you realize that in your kitchen, you need an additional tap. So in that case, what will happen is, it involves too much of time, too much effort. You need to get approval from your association members, because you are not the only person living in that apartment, right? So you need to get approval from the association members, and also you need to justify that, right? So, and also it involves too much of breaking. So you need to bring in the tap from year to year. You need to, right? So you need to do a lot of plumbing work, and it can also cause damage to the overall structure of the building. It is always good. That's the reason why what we do is we will have a blueprint in place before we construct the house. It is always good having a blueprint in place before we construct the house. Okay, similarly, when it comes to any software project, be it any applications. So let's say you want to develop a website. Before you develop a website, right, so you need to have this solid data modeling in place. If you don't have this solid data modeling in place, what will happen is, later point in time, let's say you are in a development phase. During the development phase, if you find some problem in the data model, sometimes you'll have to do complete rework. Okay, so data modeling has a huge impact on the cost and time it takes to build a new application. This is one of the important stages of any software development project. So without data modeling, you cannot get a clear idea of what your database and what data it will have and how your application will be built upon it. Okay, so it is very much important doing the data modeling, okay, before you proceed with building your application. Okay, so it allows us to identify the possible relationship between different pieces of information. So now you might be asking this question, right? So why should I learn data model? Though it is part of the software development life cycle. See, in the software development life cycle, the first phase of the software development life cycle is requirements phase. The requirements phase, our business analyst or customer business analyst will liaise with their internal stakeholders and then understand each department needs, what kind of reports they needed, what are their current pain points. They will talk to them, they will gather all the requirements, and then we do some kind of requirements validation. We validate the requirements gathered by our business analyst, right? Finding any gap, okay, in case of any gap or something based on positive. Right? So what we do is side by side, as part of the requirements phase itself, we'll come up with something called conceptual data model. Conceptual data model. So what is conceptual data model? So as part of the conceptual data model, we identify the tables or the entities that are required to complete a specific project. Let's say you are building a your customer is into grocery business. Okay. So in this case of grocery business, right? So they want to, so if you need to represent a data model for the grocery. So in that case, you need to identify all the entities or tables that are part of this grocery business or business process. Okay. So customer is one of the entities. Customer and products and category and location. These are the entities, these are the, high level. At the high level, at the 10,000 feet height, you will, while talking to these stakeholders, you will get to know, oh, these are the entities that are required. In addition to that, you need to have the transaction table, sales table. So sales table captures day-to-day, the transaction level details in it. Okay. So in that case, right, so as part of the requirement phase itself, we do the conceptual data model design. Okay. At the high level, we understand what are the tables that are required or the entities that are required, and also how these entities are related with each other. That is what we do it as part of the conceptual data model. Okay. So there are three types of data model. One is the conceptual data model. The next one is logical data model. And finally, physical data model. This is where we implement the data model. Okay. So conceptual data model is the big picture. And the logical data model helps us to understand how the business look at the data. Okay. How the data is actually held in the database. So that is what your physical data model is all about. So conceptual model is something like, the big picture. So I would say, right, even in this case also the conceptual, how the business look at the data. Business people, they don't have any idea about what is data model is all about. They don't know normalization rules, and they don't know what is denormalization, what is star schema, what is snowflake schema. They don't have any idea about it. So all they need is they want to make sure that we are not missing any of the tables. They just take a look at, okay, customer, products, category, and location, and we have something else, subcategory. We need one more thing, customer. When they look at the entities that you have identified after speaking to these different department heads, right? So you will get to know these are the tables that are required, and also you need to have the date table, right? So date dimension. And all these tables, once you identify it, you are going to review with all your stakeholders and then vet it with them. Once they say everything is fine, you did not miss out anything, right? So then what we do is the next step is logical data model. As part of the logical data model, what we do is okay, in the case of logical model, data model, what we do is right? So we identify the attributes that are part of each and every entity. For example, customer is an entity. And so, okay, I just go here. So customers, right? So customers, see, as part of conceptual data model, since let's say in this case, you are working with grocery customer. Okay, they are into grocery business. You are working with the grocery customer. So while talking to them, you are able to understand the business process at a high level. Okay, customer places an order, and products appears on orders, and finally, right, there is a cardinality. What is cardinality? Cardinality is nothing but relationship. Cardinality is nothing but how these tables are related. Okay, so it is also called as a degree of relationship. Degree of relationship. So degree of the relationship between the tables. The degree of relationship, such as customer places 0 or more orders. 0 or more orders. The star represents many side and 0 represents 0, right? So a customer may order a product. So let's say you have 1 million, your customer base is 1 million. Not necessarily all the customers have to order the products on a daily basis. Some customers, they may order it. Some customers, they may not order it. Some customers, they may order it with our competitor also for some day because of sales or deals, something like that. Okay. The customer, right? So customers, they place a 0 or more order, and order is placed by 1 or more customers, right? So we can say that way. So order is placed by 1 or more customers, and products appears on 0 or more orders. The same rule is applicable here. This is many side, this is 0 side. So though we sell 1 billion products, it doesn't mean all the products have to appear in all the orders, right? There are some products we don't sell it. There are no demand from the customers. Customers are not at all ordering some products from us. So as part of the conceptual data model, right? So we are able to understand the business process, and we identify the entities that are required, and also we are able to understand the degree of relationship. 0 customers, right? Customers, may order a product, or they may not order the product, or they may order. The customers may order 0 product, or raise 0 orders, or they may raise more than one orders also. Okay, so these are all the business facts, right? Needs to be included in this case. Now the question is, who is responsible to create the conceptual data model? So the data architects, they are the one responsible for creating the data model. Architects. Okay, so again, so the customers places the orders, and 1 or 0 or more products appears on the orders, and these products, right, belongs to more, the categories, right? So falls under some categories, and also these products, we sell it across different stores. So this is my conceptual data model. When it comes to logical data model, we go one step further, and we define the attributes that are part of each and every entities or tables. So customer, in the order fact table, we specify what are the columns that need to go in here. In the customers table, what columns that needs to get into this one, what are the columns that get into each and every entity. We will define it as part of the logical data model. And also in the case of logical data model, we implement the business rules, something like in the case of customers table or entity, right? It should have at least one unique identifier, something like customer key. It should have at least one unique identifier. Okay, you see, likewise, right? The customer will dictate all the business rules, all those things you need to capture it as part of your design document. In the requirement phase itself, you will get some high level understanding about the requirement, and the high level design document also, right? We capture all the business rules. In the low level design document, we specify, in some cases, right, we specify the query itself. So you can use this SQL query, or you can use this logic to derive this business logic. Okay, so we define it everything there. So in the case of conceptual data model, we just identify the tables and how those tables or interact with each other. In the logical data model design, we understand the business rules, and also we identify all the attributes that are required for each and every tables or entities. So you might be familiar with this one. If you are not familiar, so see, these are the notations. We'll be using it as part of the data model design. So here what it says, 0 to 1. So if you see this kind of notation, which means 0 to 1, your customer may order 0. The customer may buy 0 product, or 1 product, some cases. Okay, so if you find this notation, that is what it says. This is 1-to-1 relationship. Okay, so 1-to-1 relationship, something like Each employee will have only one unique employee ID. Each employee must have a unique employee ID, but it should not have a duplicates. So this kind of one example for one-to-one relationship. If you find the crow's feet, we call it the crow's foot or something like crow's foot. Okay, so if you find this kind of notation, that means zero, right? If you see some circle, after this crow's feet, that means zero or more. It's a product, may not appear in all some. So there are some products it may not appear in the orders, and there are cases in a single order multiple products can appear. Okay, and this is one or more. Okay, so if you see some notation like this is one, this is zero, zero or more, one or more, this is one to one. You just think this kind of one. Okay, and zero or one. Okay, so these are the notation we use it as part of the data model design. Usually what we do is we ask the customer as part of the development phase itself. Let's say let's say they recruited you as a developer or senior developer. Before you start developing your reports or dashboards, you need to make sure that you're asking the data model design, Irwin model or something like that. Okay. So see, if they already have the data warehouse, you don't have to ask them the model and all. Okay. You can go and explore it. Okay. But still, in the design document, they specify everything. Irwin model. So in the Irwin model, you can find something like this. Okay. It's, zero or something like this. Okay. And so the crow's feet. Okay. Crow's feet. Something like that, right? So something like this will be there. So these notations will be there. Okay, these notations will be there along with these tables. Okay, so with this notation, you can understand very clearly. Customer zero customers. Customer may order a product, or more than one customer can order a product also. Okay, so zero products. There are some products they may not order it. But a fact, in this case of sales, in the transaction table, more than one product can also appear as part of each order. Okay, and categories, each category, right? So we'll have, there are some cases a single product can appear in more than one categories also. Okay, so each category has its own rights of products. Okay, and it has some set of products, and so stores across locations, they sell different products, or customers order products across stores, and they order more than one products also under different categories. That's how you need to understand the big picture. As part of logical design, we understand the we identify all the attributes, and then next one is the physical data model. In the case of physical data model, we define the data type for each and every column. So for example, customer key is a let's say I'm going to say string or character text data type, and customer key is a text data. We are going to define the data type and the width of them also. So text data, customer key, and the width is something like 10. So date key is a date column, date data type, and then store key is also a text, and the width is at least 12 or 15 we specify. So in general, as part of the physical data model, so we define the granular detail, like for each or we specify the data type for each column and also the corresponding width for each column. So as part of the physical data model, once you define the data type and more the width of each and every column, so the next step is they are going to create the tables in the database. Once they create a database with the relationship, everything in place, they start load the data. Who will be loading the data? Database administrator. So database administrators, and then see data architects. They are the one responsible for designing the data model. Okay, along with the business analyst. So there are some cases, the data architect themselves, a techno-functional guy. He knows technical part and he knows the business part. But there are some cases you have a separate business analyst. He is the one talking to the customers, all the stakeholders, different department, and then he is the one gathering the requirement by conducting the workshop with them. And then what he does is he will help him. Okay, so these are the expectations based on which, these two guys, they will come up with the conceptual model, logical data model. And finally, once the logical data model is defined and physical data model is defined, the data architect will work with the database administrator, and he is the one responsible for creating all these tables into your database. Okay, so what is the data modeling? This is a typical data modeling process. Identify the entities, which are nothing but the tables that are required for your business process or your project, and identify the key properties of each entity and identify the relationship. The next one is map the attributes to entities completely and visualize the data. Okay, and then assign keys as needed, primary key, foreign key, and also define the relationship, whether it is 0 to 1 or 1 to 1 or 0 to many or 1 to many, and the degree of relationship also we identify and then we finalize our data model design and then share it with all the stakeholders and vet it with them. Once they say go ahead, then we are going to implement those data model into the database, the data warehouse database. So got it? So that is what physical data modeling is also, that is what we do it as part of the physical data model. Now the question is, why do I need to have why do I need to learn all these things? So you are talking about data business analyst, data architect, database admin, but I am a Power BI developer. So why should I learn all these things? Okay, so not all the projects you have the luxury to have the data architect. So some projects, they will have only the business analyst. So you will directly talk to the Power BI developer, or senior developer, or team leader, and then you will dictate all the, or you will explain in detail the requirements or the business logic from the customers. Okay, and as a developer, see, that is what happening. Even my students, they call me and they ask me, so this is what my team lead asked to do, right? So what logic, how can I implement it, right? Still, even though the course was over, still they are calling me and asking me, right, how to do that in real-time scenario. I got stuck, I could not understand the requirement, right? So but that's what, so if you are if you are lucky, right, you will have a data architect, dedicated data architect, database administrator. But database administrator will be there for any project. But some cases, right, the data architect may not be there. The business analyst will talk to you directly. He'll ask you to, right, so you create the relationship like this, and so these are the degree of relationship that you need to define it as part of your data model. So everything is fine, and but still you are confused. How why should I need a data model? First of all, right? So if you have a data model, you are not going to miss out any of the pieces. If you identify all the entities or tables that are required and all the columns that are required as part of each and every tables, once you start getting into the development phase, you don't have to run pillar to post to look at, hey, this column is missing and this table is missing, right? You don't have to do it. It doesn't involve any kind of rework. Rework is one of the overkill in any development project. Beyond all these things, I just directly jump into the Power BI desktop, and I'll show you the importance of data model. Because when it comes to Power BI, without having a relationship, right? So when it comes to Power BI, data model is something like a relationship. You need to define the relationship. Without defining a relationship, you cannot filter the data across the table just by itself. I'll just show you one example here. So these are the tables I already loaded. I just show you where these tables are available. Already I shared with you all this link. Look here. So you have something called retail data sets.zip. If you download this, I'll just share this in the chat window. You just copy paste this link into your mobile phone or in your laptop. Okay. And now you watch my screen. Don't get distracted. Okay. Look here. So these are the files are already available in that zip file. You just load it, get data, an Excel workbook, load the dim category, product, NC, sales, all the things there. The next step is what I'm going to do is, but don't do it, just watch it now, what I'm doing. So I just clicked on this clustered column chart. The moment when I clicked on it, automatically it got dragged to my report canvas. Okay, fine. The next step is I'm going to drag and drop the product name here. If I scroll down in the NC sales table, I can see something like sales amount. Sorry, I made a mistake. You need to select this visual and then you need to drag and drop it. Otherwise, by default, it will create a column chart for a numeric variable in the case of report canvas. Look here. Okay, what I'm going to do is I just press Control C and Control V. Copy paste. How you do in Word document? Same thing. Control C, Control V. You can select a visual, and if you want to duplicate it, you can see Control C, Control V. Okay, and then it will create a duplicate of that one. So now what I'm going to do is I select this visual, and I'm going to drag and drop the category here. I'm going to remove the product name here. Instead, I just put category here. So you can see here very clearly, we have in this case 5 categories are there. In each category, how much sales we made. Just by looking at this chart, we are able to quickly understand. In the case of dairy category, we are doing great job, right? The sales is very high in dairy category compared to other categories. Okay, you got some insight, fine. So what I did, look here, when I clicked on this visual, this chart, on the right side, you can see category, right? The category, when I dragged and dropped the category here, right? So it made part of my axis, which is my x-axis here. And sales amount is part of my values field, right? This is where the sales amount is in y-axis, the category is in x-axis. So the category comes from which table? This table. And the sales amount comes from which table? NC sales. Now I just go to the model view. This is my model view. I did not do anything here. Simply I imported these 3 Excel files into my Power BI desktop. When I clicked on this, I could see that automatically the relationship got created in Power BI. In the case of Power BI, this is called Power BI, the model view. The model view, what is the relationship? The link, whatever you see, right? When I hover the cursor on top of this one, on the left side cat ID, right side cat ID, these two columns got highlighted. The dim product, you can see the cat ID column got highlighted. On the left side in the dim category table, cat ID column got highlighted, which means these two tables, a relationship has been created with the common column cat ID. All right, you can see star here. So one here. So on the left side of this table, right? So you can see one. On the right side of this table, sorry, left side of this table, you can see star here, which means one-to-many relationship. Right, for the single, right? So for each category, right, you have one or more products. That is what it says. The products appears many times in this sales transaction, right, table. The relationship got created automatically. So now if I go back here and see the product name also, the product name comes from product table. Look here, when I select this one, the moment when you select a visual in the report canvas, on the right side, automatically you will find the tick mark here, which means for this visual, what columns from which table I have used it. Because of this tick mark, you are able to quickly understand, okay, from which table the columns are coming for this visual. Look here, product name from product table, dim product, and sales amount comes from NC sales table. Fine. So product name and sales amount, these two columns comes from these two different tables. And similarly, category and sales amount comes from two different tables. Right. Now I just go back to the model view. I just click on this. I'm going to right click on it. I'm going to delete this relationship. The link I'm going to delete it. Right click on it and delete it. Or before that, I just delete this relationship. Okay. Instead of doing that, category and product, I'm going to remove the relationship. Next step is, if you come and see, look here, between the category and product table, I removed the relationship. Now it is not doing the filtering properly. You remember, this term very clearly in Power BI. If you remember this, you will be able to understand whenever I talk about relationship in the later sessions. So the moment when I remove the relationship, it is not doing the filtering correctly. For all the category, it shows the same value. It is not doing this. So what I do is, so now I selected this visual. I just click on the table. From the clustered column chart to, it will get converted as a table chart. If you want to change from one visual to another visual, you can choose whichever type of visual you want, you can choose it. Okay. So now I can see in terms of numbers very clearly for each category, the same value repeated. So this is the total sales, right? So of these total sales, how much sales we made in each category, it is not doing that. It is not showing that here because we don't have the relationship. I removed the relationship. I just go back here and I create the relationship between these two table now again. Okay. I removed it for the demo purpose. How do I create the relationship? Just select the column and then drag and drop it to the target tables column. The same column you need to drag and drop it. Cat ID in cat ID. I just dragged and dropped it. It will take some time. I do it one more time. I think because of this application, it was okay. It got created, right? So just dragging and dropping is not sufficient. You need to make sure that you are linking the tables with the correct columns. Cat ID and cat ID should get linked here. Okay, so now you might be asking some questions, right? So why should I use cat ID here? Can't I use some other column? That and all we'll discuss it little later. Let's go step by step. Fine. So I removed the link or the relationship between these two tables. Now I created the link once again because in the table visual also, look here. This is the overall total sales we made across all these 5 categories put together. And each category, what is the totals? Look here, it's so powerful, Power BI, isn't it? I did not write any logic here. I did not write any formula here. Column or cell level formula like in Excel, right? In Excel, we need to specify the formula. In the, divide the total sales by each category sales and then specify the values. And here I did not write any formula. I just simply created the relationship between category and the sales table. This sales table and the category table and product table, I created the relationship, right? Because of the relationship, Power BI automatically filters the sales tables, sales amount for each category, total sales amount for each category. Automatically it goes and computes and it filters and it shows the correct value. If I remove the relationship, it shows the 4, 5, 6, 1, 4, 9 repeatedly here. So from this, what we understand is relationship is very much important when it comes to Power BI. Without data modeling, without creating the proper relationship between the tables, it will not do the filtering. You will not get the accurate values like this. Okay. So hence, now you understood why data modeling is important from the Power BI point of view also. Okay. In simple term, the slicing and dicing is not happening. Slicing and dicing is not happening. Or in simple term, the filtering is not happening if you don't have the relationship. What do you mean by filtering? I just show you with this example. So this is what is happening. For example, in my case, I have a country table. You assume that instead of category, we have a country table. Okay. And then we have a sales table. Okay. So we have created the relationship between these two tables using which column? Which column we have created it? Where the arrow points. All of you please type it in the chat so that I can make sure that you are able to follow me or not. These two tables got, so there is a link here, right? So these two tables got, yes, Shreyas, very good. Shreyas mentioned country ID because the link is pointed here. This arrow is pointing here. Hence, we have created the relationship between these two tables using the common column country ID. Fine. So once you define this relationship in Power BI, what happens is it goes to the first record in this table. Okay. And then, right, so it goes and filters the sales table for the corresponding, the first record value. Look here, this is what is happening. So that I highlighted in red color. So what happens is the filtering. Whenever I say filtering, this is what, this is what should come into your mind. First it goes to the this table, dimension country table, and then it goes to the first record. And immediately what it does is it goes and filters the data that are related to United States in your sales table. And then it applies the aggregation. So 2,500 plus 1,000, how much? Plus 250 plus 350, 10. This is what I meant here, filtering with relationship. Since we are having the relationship, it does the filtering automatically. Okay, I just go back to the model view here. In this case, what happens is I have used category here, category, and here the category table is not directly linked with sales table. In the real-time scenario, you will encounter this kind of relationship. Okay, but the category table is linked with product table, and product table is linked with sales table. Hence, category table can filter my sales table. In the category table, what data is there? Let us look at it. So in the category table, beverages. You just imagine here. Okay, here you have beverages. So it goes C001 is your category ID and category is beverages. Here C001 and beverages. In the sales table, it goes and filter all the beverages related records only, and then it does the sum. It applies the sum. That is what it did it here. That is what happened. Okay, in the category table, first record was okay. In this case, okay, let's it goes by dairy. It first record was dairy. It considered the first record as a dairy, and then it went to the sales table, and for all the dairy related category, it applied the sum. Okay, so now you might be asking, so how it knows the sum? Okay, look here on the right side down here. When I click on it, here sum, by default it is sum. The aggregation function is sum here. You can choose whichever aggregation function you want. I don't need sum for each category. I just need to know the average sales. You can select it here, right? So you can do it there. So here the sum by default for any numeric variable in Power BI. Look here, sales amount, quantity, profit. These are the numeric variable. Even cost price, discount, list price. For all the numeric variable, it by default it applies the sum aggregation. Look here, You can see it uses the aggregation function sum by default. Okay. You don't have to specify any formula, nothing. Okay. Since we have defined the relationship between the category table and the sales table, it does the filtering automatically and it applies the sum for all the dairy related sales in the NC sales, and it computes the total sales automatically. It does. It's a fantastic feature, isn't it? So we don't have to write any formula, we don't have to write anything. Simply just drag and drop. Once you create the relationship, so now you understood how much it is important to define the relationship between the tables. Now the question is, do I need to create the relationship, the link? You don't have to create it. The moment when you drag and drop, or the moment when you load the files into the Power BI desktop, it automatically detects the relationship between the tables. But still, it is advisable, right? You need to create the model, data model, better you create it manually. I'll explain you why. Okay, there are some issues. See, in this case, in this table, I have a column by the name of cat ID is there. In here also cat ID is there. Here, if you see the the column naming convention, cat space ID, but here cat ID is there. Intentionally given here. Still, Power BI has an intelligence to understand, hey, cat ID in this table and cat ID, in this table are common between these two. Link it these two things. And then next one is, if I hover the cursor, you look here in the NC sales table, there is a column called product ID. Here I have another column called product ID. Since the naming convention for product ID is same between these two tables, it was able to identify the relationship between these two tables automatically. For example, instead of product ID, if I specified something like product key, then it will have a hard time to find out the relationship between the columns. In that kind of situation, you will have to go and manually drag and drop it. So this is here, let's assume that you have product key, you have product ID. As a developer or, as part of the project, very well, this product ID is nothing but this product key here. So you need to link these two things manually, right? So in that kind of situation, if the naming convention is not same, you need to manually go and define it. Or the other approach is right click on it and you can go here, right click on it, rename the column. Here, let's say you have product key is there, but here you have product ID. So very well, the product key is nothing but the product ID only. In that case, what you do is rename it as product key so that it automatically detects the relationship. Okay, the point here is, right, so why we need to do the data modeling? Because data modeling is one of the important steps, not only in the software development lifecycle, even in the case of Power BI desktop, it is very much important. Without relationship, you cannot get the accurate result. When I removed the relationship, the slicing and dicing was not happening. So what is slicing and dicing? So this is the term they use it, slicing and dicing. It is something like in the birthday, you cut the cake into pieces, right? Your slice, let's say you cut the cake and you take that slice. So if you want to take the subset of the data and for a specific country, category wise, what is the sales? Let's say you have a table called country table, and the slicer is where you want to see only in United States across all the category how much sales we made. You are slicing the data. You are just taking the subset of the data. That is what slicing. And dicing is performing specific action, right? You want to do some kind of sum of sales or average sales in each category. So slicing and dicing, in order to happen, you need to have the relationship between the table. Without a relationship, we cannot filter. Power BI cannot filter the data across table. That is what we learned. Fine, good. Next one is, I'm going to go outside of the topic, but it is relevant. I'm going to explain what is normalization. So what is normalization? So why should I know about normalization? Why should I know about normalization? when you do any data modeling, you need to follow certain rules. Okay, you need to follow certain rules to do the data model design. So you know very well what are the tables that are required and what are the columns that are required for each and every table and what are the data types and width of the columns, everything you know, but still you need to do some kind of normalization when it comes to online transaction processing. Listen, it's a very interesting topic. Just by knowing what is what, it is not required. That's why I'm talking about this normalization. See, in the case of OLTP system, what is OLTP? You just assume that Amazon, you order all the products in Amazon website, that your order, your contact number, your shipping address, everything gets stored in the OLTP database, some database. Okay, it's a OLTP. We call that a OLTP database, online transaction processing. Okay, so here how they do the data model design is, right? So they use normalization technique in order to the data model design. Okay, in the case of OLTP databases. But why do we need to worry about this one? Why do I see this is OLTP? We are not going to work on OLTP databases. Why should I learn about normalization? That's a good question. But the point here is we have something called data warehousing. Data warehousing is also a database. Okay. This is just the concept. Data warehousing is a concept. OLTP is a concept. They use different terms, but it's all the same database only. But there is a difference when it comes to the concept. In the case of data warehouse, we store the historical data. Okay, I store the historical data as a Power BI developer. I'm going to work only with the data warehouse. I'm going to pull the data from here. I'm going to build the report, dashboard, everything. Why should why you need to know this one is for the data warehouse also there are majority of the problem. You need to pull the data for the data warehouse, the source of the data coming from your OLTP database. You need to pull the data from your OLTP system and then you need to do some kind of data transformation and then you need to load it into the data warehouse, the clean data, right? So you need to pull the data and then you need to convert this raw data into pre-processed data. You need to pre-process the data and then load into data. So once the data is pre-processed, if the data is available in the required format or shape, then if you start develop a report or dashboard, your effort is very less. Okay. So once your data warehouse has the clean data, right? So and then what you need to do is still you need to do some, you need to apply some kind of business rules or you need to use some formulas to compute profit, net margin, net revenue, so on. So still you need to use it, but the data, whatever you stored here, it doesn't have any redundant data. It doesn't have any duplicate record in it. It doesn't have missing values. All the issues. So now the question is, from the OLTP system, you need to bring in the data and you need to do data transformation, everything. In order to bring in the data, if you understand the OLTP system, the OLTP database, how they did the data model design, everything, right? So if you know that, it will be good. Okay. So in that case, right, you need to learn normalization. So how, in the case of OLTP system, they do normalization. As part of the data model design, they do the normalization. Okay. So now what we will do is we'll understand what is normalization. In simple term, we divide the larger tables into smaller tables and links them using relationships. When it comes to normalization, what we do is we divide the larger tables into smaller tables. We don't store all the data into single table. We don't store all the data into single table. So OLTP stands for Online Transaction Processing System. Shreyas has a question, what is OLTP? OLTP, Online Transaction System. Anyhow, I'm not going to discuss about this. You will get overwhelmed at this moment. Online Transaction Processing. Online transaction processing. All right. So that is what OLTP stands for. Even data warehouse, they call it as a OLAP. Online analytical processing. Online analytical processing. The purpose of data warehousing is different. The purpose of OLTP database is different. Okay. I'll explain you a little later. Okay. So now let us see what is normalization. We are decomposing the larger tables into multiple smaller tables and link them using relationship. That is what normalization is all about. See, even in your a simple analogy, maybe it is a stupid analogy. Let's say you bought all the vegetables and you put it in a single jar in your house. Or you bought all the ingredients to prepare some your favorite food. If you put everything in a single thing, right? At the time of cooking, you need to you need to search each and every item in the single thing, and you need to take it out, right? You rather if you put it in different things. Let's say you chili powder here and masala powder in a separate thing, it'll be easier. Okay, you know very well. Okay, this is available. This one is available here, and this powder is available here. You can bring in here and you can mix it, and then your job is pretty easier. The same analogy is applicable. Instead of storing all the data into a single table, we divide this larger table into multiple smaller tables logically. Okay. So by doing so, what am I going to do? We can eliminate the data redundancy. We can improve the data integrity. And also we can overcome the undesirable characteristics such as insertion anomaly, update and deletion anomaly. We will take a look at each and everything. Okay. So before we proceed with understanding what is data redundancy or data integrity, all the things, right? First, let us understand, what is the insertion anomaly, update anomaly, and deletion anomaly. Once you understand this, you will get to know, why normalization is required. So first of all, why do I need to do normalization? In order to do the normalization, there are some rules you need to follow it. Before we get into or before we jump into understanding the different rules, first of all, let us understand why do I need to do a normalization? If there is a problem, only then you need a treatment, right? So there is a problem. So what kind of problems can happen if you don't have the normalized data? It can cause some kind of insertion anomaly, update anomaly, deletion anomaly. Now let us take a look at this simple data set. So here you can find the employee ID and employee name and the department which he belongs to, and you have another column, or let's you have something like department group or something like that. Okay, there's something like this. Here, these informations are related to your employee, and these informations are related to department. If you store both the thing in a single table, what will happen is you will end up something like insertion anomaly. Insertion anomaly. What do you mean by insertion anomaly? Supposing you are going to create a new department in your office. Let's say you have something called sales department. You want to have something called sales department, and this is some group is there. Let's sales _ west, some group name, okay, and department name. But in this table, the employee ID column is a key column. This is a key column, primary column, which means this column should not have any missing value here. Okay. If you insert any record or any value in any other column, you need to make sure that you are going to insert the value for this column. Without inserting the value here, it will not allow you to insert the value for other columns. And also, you cannot insert duplicate values in this column. Okay, now you understood. In the case of key column, you're not supposed to have any blank values. Okay, so but your manager says, okay, we are going to start a new department, and says and go and insert it. If you have all the detail in a single table, what will happen is you cannot create the department alone. So you need to assign some employee, because you have not yet recruited anybody so far. So in that case, what will happen is you will not be able to insert the department name alone here, because the employee ID column is a primary key column, you cannot, it will not allow you to insert duplicate records, sorry, missing values. It will not allow the duplicate records, and also it will not allow the blank values here. Though you want to insert only these two values, still you need to, in this mandatory. If you don't insert the value here, it will not allow you to insert this record. This is one of the problem, right? So this is called insertion anomaly. The next one is the deletion anomaly. There's something called deletion anomaly. So what is deletion anomaly? The deletion anomaly is the unintended loss of data due to deletion of other data. For example, you wanted to delete this group, right? So what you are doing, you are using a delete command. In SQL, there is a command called delete from, this is employee table, where department group is equivalent to beta, alpha. Your intention is you want to close this group. You don't want to have this group because there are some internal discussion based on some business internal discussion with your managers. You decide to remove this group. So when you remove this group, what will happen is this department name will also, the entire record will get removed. Not only the entire record will get removed, and wherever the beta, alpha, PSI is there in your data set, that record will also get removed. Actually, you want to remove this one only, right? So if you use this command where delete from emp, where the department group is beta, alpha, say what will happen is this record and this record. So, but still, these two employees are working in your company. You are losing your employees' data here. You are missing that. This is called your deletion anomaly. And other one is called your update anomaly. Update anomaly. For example, Longfellow, right? So Longfellow was working in accounting department, or you, you're working in a accounts department, and now, right? So he wants to switch over to CIS department. Okay, later point in time, he moved to CIS department. So in that case, you will have to update here and you have to update here. So he is no longer part of accounting, right? So you want to make sure that, right? So you want to override this value. So he is going to be CIS and CS. Unnecessarily, you need to update in two different places. But he belongs to two different, group. Still, his record should be there. But what will happen is, right? So you will have to update in two different places. In this case, oddly, we have 5 records. You just assume that if you have, in the case of TCS, when I work with these, right? So almost 5 point some lakhs, well, 5.2 lakhs employees are there. And right, if you have to update such a big table, it'll take a lot of time. Update is an expensive process. It'll consume a lot of memory, CPU, IO, everything. Okay, so this is another example. Update. You have to update a single person's multiple records. So with data modeling, by doing the data model design, right, what we are doing is by applying the normalization technique, we divide this single table into 2 different tables. In that case, what will happen? If you wanted to remove this group, you can remove it, right? So it will not remove the employee's detail from your payroll, right? From your payroll table data set. It will not remove the employee ID. Rather, only this group will get removed. That's all, right? So let's say beta, alpha, PSI has 2 departments. So I don't need this department. I want to retain only this department. Let it be there, right? So it will not cause the deletion anomaly. Insertion anomaly, if I want to create and introduce or create a new department, you can insert it here, because all you need to specify department ID, department name, and the location group or something, location something, or group something like that. You can insert it. It is not mandatory. You have to specify employee ID here, because these two are 2 different tables. By splitting this data into this single data set into different data sets. Now we are able to overcome insertion anomaly, deletion anomaly, update anomaly. Right? This is a simple example. We cannot, do it. We cannot split this. Now the question is, so how will I get to know? Do I need to split this entire data into only 2 tables or 3 tables? To answer to this question, you need to learn 3 types of normal form. This is a basic normal form. First normal form, second normal form, third normal form. What is first normal form says? All rows must be unique. Each cell must contain an atomic value, single value. I just go here. Look here. I have 2 columns here. And the first rule is each row should have unique value here. So here I can see John here. But John here is duplicate. I can see duplicate here. Maybe these 2 guys are different, or maybe it is a duplicate. But if you look at the products column, you have more than 1 value stored in a single column. This is violating the first normal form. What is the first normal form? Second rule says each column or cell must contain a single value. But here in the single column itself is stored multiple values. This is not the right way of doing it. Another thing is we have some duplicate is there. Next, what I do is this is violating first normal form. So what I do is to address this issue, I'm going to introduce a new column called order ID. The first rule is all rows must be unique, but John name is appearing more than one time, more than one record. Now, when I introduced a column called order ID, John, right, maybe he is the same guy, but he raised 2 different orders. He ordered 2 different times. This order ID, in order ID 1, he ordered fries and Coke in the past. In order ID 3, he ordered fries and Coke again. Order IDs are different. This way, I addressed the duplicate issues, right? Duplicate issues. Because the order ID is unique value. Here we don't see duplicate values. Here order ID is 1. This order ID is different. Though the customer name is same, the order ID is different. By introducing this one way of addressing the, the duplicate record issues. The next step is, but still, the second rule says you are supposed to have, individual value, single value in each column. But here you have more than one value is there. So what I do is I'm going to split this into another table. Look here, products. The products, I put it in a separate column. I put fries, Coke, each and every value. I'm going to specify each and every product separately. Fries, Coke, fries, nuggets, cake, Coke, fries, Coke. I splitted products from this table. And if you look at this table, it is meeting the first rule of my first normal form. So here, all the rows are unique because order ID is unique here. We don't have any duplicate here. Though the name is duplicate, order ID is unique. But each cell, now somehow we address this issue. Each cell, now the product, right? So in this cell, we have only one value. In this cell, we have only one value. In this cell, we had more than one value, but now we stored single value in this column for all the products. Now, how do I relate this one? If I put separately here products, how do I get to know which products ordered by whom? Right. So in that case, what I do is we create order ID here, one more column here, right? So with this order ID, you create the relationship here, right? So only when you create an order ID column here, you can relate this one with this one. So order ID 1, 2 products were ordered, fries and Coke. By whom? John. Right? So the common column between these 2 tables of order ID. So order ID 1, in the order ID 1, there are 2 products ordered. So here duplicate is there, let it be there. Right? So products are different. Okay. So by linking these 2 things, we get to know John has ordered 2 different products in order ID 1. And Mike has ordered 2 products in order ID 2. John has ordered 2 products in order ID 3. In order ID 2, yeah, my case order 3 products. Okay. So now we are able to solve the issue, right? So now it is in first normal form. Now you understood we have splitted a single table into more than one table. For this, we have used first normal form. Next one is second normal form. If a table has to be, or if the data model has to be in the second normal form, first it should meet with the first normal form. And then, in addition to that, there should not be any partial dependencies, which means all non-key columns must be fully functionally dependent on the key column. Let's take this example, student ID and course ID and course fee. So the student ID is 1, and this student, whose ID is 1, he has taken 2 courses. Okay, the student ID 1 and course ID, these two things are composite key. Both of them are key column, but it is a composite key. The combination of 2 columns only you will be able to understand which course was taken by which student, right? The student has taken course ID 1, this student has taken course ID 2, this student has taken course ID 1, this student has taken course ID 3. The course fees, we mentioned it here. If you look at here, for the course ID 1, the fee is 500. For the same course ID 1, the fee is 500 only. So the course fee is depend on the course ID. But course fee is not depending on the student ID, right? Student ID is, course ID is depending on student ID, or we can see student ID is depending on, or course ID depends on the student ID, right? So for this student has taken 1, 2, this student has taken course ID 1 and 3. So these two columns are fully functionally dependent. Okay, but course fee is not dependent on the student, right? Dependent on the course only. If you take up some, you want to do BTech computer science, the course fee is different. Depends on the course, BTech computer science, right? So, and BTech IT, information technology, depends on the course, the fee is determined. But depends on the student, the fee is not determined. Hence, the course fee and student ID is not fully dependent. In that case, we need to break this into separate table. So what we are going to do, course ID and course fee, we keep it in a separate table. But in this case, these two columns are composite key. Though it is a composite key, the course fee is depending on only this, partially depending on this key column. It is not fully depending on these two key columns. It is partially depending on, hence, right? So it is violating the second normal form. So now what I do is, to address that issue, I'm going to split this table into 2 different tables. So here, simply what I did, I just moved the course fee into separate table. In order to understand for which course, which fee, I need to have the course ID. Here I need to have the, because these two are dependent on each other, right? So in this case, we are going to create the relationship between these two, link. In Power BI, remember, we create the link, right? The line between the two tables based on the common columns, course ID and course ID. So with this course ID, we are able to understand for course ID, what is the fees? 500. And even for him, the course fee is 500. So now it is in second normal form. Got it? And the next one is, now the both tables do not have any partial dependency, right? By implementing this second normal form, we make sure that there are no partial dependency between the columns. Right? This one is fully dependent on this one is fully dependent on this one. Next one is third normal form. In order to say that my tables are in third normal form, it should first meet with first normal form and second normal form, and then the third normal form. What is third normal form? No transitive dependencies. All columns must be fully dependent on your primary key, not by other keys. This is very simple. I've taken a simple example. For example, the employee ID and employee name, right? It is, the employee name is dependent on the employee ID, and the employee zip, yes, this employee lives in which location, fine. An employee state, employee city, and these 3 columns, if you look at it here, right? So these 3 columns or depending on this one, right? If somebody tells you the zip code, that is more than sufficient for you to understand in which city, in which district, in which state a person lives. So these three non-key column depends on other non-key column or other column, okay, other column. But here it is a key column. What do you mean by key column? Primary key column. Primary key or unique key column. In this case, let's say primary column, because you don't have any duplicates here. You are not supposed to have any duplicate values in your table. So here it is a primary key column. All the, as see, the third normal form, what it says is there should not be any transitive dependency. Transitive dependency in the sense all the columns should fully dependent on the key column. So these are the non-key column, but the non-key column depend on another column. Hence, what we do is it requires splitting. So employee zip, and the 4 columns you put in a separate table, but these 3 columns you put it in a separate table. Look here, the employee, employee name, employee zip, right? So these 3 are in single table, and these 3 depends on the right. So this one zip, right? Employee zip. So put it in a separate table. Here, non-key columns are dependent on other column. It should fully depend on the primary key. That is the rule, right? It is not fully dependent. So what is the difference between second normal form, third normal form? Second normal form, all the columns should be fully determinable by the key column, primary key column. In the case of, look here, this is the example, right? So here, the course fee is not fully dependent on this one, right? Fully not dependent. Hence, we splitted this and we stored a separate table. So here, this column is fully dependent on this key column. And these 2 columns are composite key. It depends on each other, and so it depends on the course ID, right? So the next one is the third normal form. What means non-key column should not depend on other non-key column, right? So that is the difference. So in that case, what we are separating is separating it in a 2 different table. We store it, the data in this one. So this is how we make sure that when we do the data model design, we apply these kind of rules: first normal form, second normal, third normal form, and then we have something else called Boyce Codd normalization form, multi-value. I'm not going to discuss about that one now. Okay. And so we apply this normal form, make sure that we are splitting the tables logically. Why we are splitting the tables logically like this is, right, to avoid the redundancy, to avoid the insert, update anomalies, insert, update, delete anomalies, right? If you keep it logically in separate tables, more than one table, what will happen is even if you remove one department, or if you remove a specific group, the employee name will still remain in your company. Okay. The insertion, deletion, update anomaly will not occur. The data redundancy will not be there. Okay. We'll discuss about the data redundancy little later. So all these things are related to normalization. Normalization, we do it as part of the OLTP database. Remember the Amazon orders, whatever you order it in Amazon, that data will get stored in the OLTP system. Daily transaction, right? Whatever you do it, that will get stored here. When it comes to data warehouse, what we do is we use something else called star schema. We use denormalization. We use a technique called denormalization. Denormalization. When it comes to OLTP, the challenge with OLTP is sometimes what will happen is you are splitting a single table into 3 tables, 3 different tables. Sometimes it's when you have a customer table. What you do is you store only customer information and you store the address ID only here, and you have another column for address, and then you have another table called zip code. Single customer table itself, they split it into more than one table. So in this case, what will happen? More the table you have, you need to use more joins. Supposing you want to know the customer's shipping address and the zip code and state, everything, right? So you need to join more than one table to get a single customer shipping code. More the joins you use it, it will slow down the performance. In the case of OLTP environment, the volume of the data is less compared to data warehouse. Remember this. The data warehouse, we store the historical data, 10 years data, or 5 years data, 8 years data, 7 years data. 5 years data itself, in the case of data warehouse, 5 years data itself, let's say it will come around, let's in the large enterprises, 5 petabyte volume of data. It's not gigabyte, it is not terabyte, right? It is, 1000 terabyte is equal to 1 petabyte. So in your laptop, you have 1 terabyte, right? 1 TB hard disk. The 1000 terabyte is equal to 1 petabyte, 1000 laptops into 5,000 laptop data. They store in the data warehouse, 5 years data. The bank, they store, huge volume of data. So in that case, what will happen is, if you have to join more than one table, it will literally slow down your query's performance. If you wanted to share a report with your manager, and if you wants to view the data in the report, it will take weeks time, 1 week, 2 weeks, he has to wait. Once he select, let's say he wants to see USA sales, United States alone, he wants to see, when he select United States, to populate the data in your visuals, pie chart, all the, sorry, not pie chart, this one, the chart, column chart, bar chart, right? It takes a lot of time to load the data there. So nobody has a patience to wait even for 1 hour, right? Everybody wants to see the information or the report in a matter of seconds. Right? So in that case, what we do is, we use a technique called denormalization. Instead of storing the single table data into multiple tables, probably we will try to combine, we will try to minimize the number of tables in the case of data warehouse. That's when we do some denormalization. So in order to do denormalization, we do something called a star schema design. We have a technique called star schema design, using which we do denormalization. And we have something else called snowflake schema. There are some projects I have seen, they are using snowflake schema design. I will show you in this training program also what is snowflake design, okay, with example. But in general, the best practice is go for star schema design. So wherein we do denormalization. But snowflake schema also, in this case, what we do is, we do normalization here also. The dimension tables, we normalize it. So now you understood the importance of understanding the normalization. Okay, we splitting the single table into more than one table. For example, you keep the product related data in product table, and then subcategory in a separate table, and category in another table. So hierarchical design, right? So hierarchically we store the data. Instead of storing all these three into a single table, we store it in 3 different tables. The dimension table, these are called your dimension tables. We'll see what is dimension tables a little later quickly. Dimension tables, all these 3 are called dimension tables: product dimension, subcategory dimension, category dimension. Okay, this is something like hierarchical. The dimension table itself, we are creating in a hierarchy. You did the normalization, hence we call this snowflake schema. But in general, we don't prefer this one, but there are some cases they use snowflake only, because the advantage of snowflake is it consumes less storage. Redundancy will not be there. If you have redundancy, it will screw up the performance, it will slow down the performance. Okay, there are some cases, most of the cases, even Microsoft recommends star schema only, but we cannot literally go with this. There are some projects, even we use snowflake only. Our customer, they mandated us to use snowflake schema, that's all. But if we justify them, then they will accept. So how, if you combine this, and what is the performance? What is the right? So if you do, but in general, at this point, you just think star schema design is the one is recommended by Microsoft. Let us go by that. Okay. So what is a data warehousing and what is data lake? So these are the terms you should be knowing it when you go for the interview. Okay, at least for the interview purpose, you should be knowing it. Star schema design and snowflake schema design, we do it as part of data warehousing. Data warehousing is a database. It's a concept. That's all. Okay. And data lake, I will explain you now. So this is a typical data warehouse architecture. Let's say these are the your customer. You joined with the company, and they are using CRM application. They are using customer relationship management, enterprise use planning, and legacy applications. Other external and other data they are receiving the data from different source systems, or they are storing the data in different applications. Okay, so in that case, what you do is, as a BA developer, business intelligence developer, or Power BI developer, or senior developer, we need to extract all the data as it is from the source system. And then we use something called staging area. In the staging area, what we do is simply we take all the files that are required by us or our management, right? You take all the tables that are required for your data analysis into a staging area. And then here what you do is, once you extract the data, you pull the data here, you do down some kind of data cleaning, data pre-processing, everything in the staging area, and then you load the data into data warehouse. Don't think staging is different. As part of a data warehouse itself, we have a separate schema called staging. So here in this place, right, we simply pull all the relevant data from these respective sources, and then we store it into this staging schema. And then we combine, sometimes we may have to join more than one table. And then you need to do left join, right join, left anti-join, and then remove the duplicate records, address the missing values, address the outliers. And once your data is ready for analysis, you load this data into your star schema. Star schema that is how we do some of the data normalization. Let's say in your data warehouse, you have different subject areas. Finance is a subject area, and sales is a separate in the subject area. Subject area is nothing but each sales related tables, all the sales related tables, you store it here, all the finance related data, you store it here. Okay. And once you clean the data, everything in the staging area, you store it in the respective schema. Finance, if it is a finance data, you push the data, the clean the data, you push it here. Likewise, okay. Once the cleaned data is available or pre-processed data is available in the respective schema, you use your Power BI desktop to pull the data from here, the clean data, and then you create the report or dashboard, and you share it with your management, or you publish the report on cloud. So this is a typical data warehousing architecture. Now the question is, what exactly data warehouse? How do we define data warehouse? How the data warehouse is different from OLTP? Data warehouse is nothing but it will have the integrated data, all the source system data, you pull it, all the relevant source system. See, for your analysis, because in your company, you have 10 different departments. Each department manager want different KPIs or metrics. They want different reports relevant to their department. In that case, what you do is comprehensively you pull all the data that are required for those report or dashboards, right? You need to pull it here, and then you clean the data, right? So that's what integrate all the source system. You pull the data. Your data warehouse will have the integrated data, and also it will have the historical data, and it is a non-volatile. This is very important. What is non-volatile? Once you store the historical data, for example, 5 years data you stored, daily transaction data you stored here. Your see, every day sales you store it in your in the data warehouse, what will happen? The size of your table will grow like anything. But if the volume of since the volume of the data is very high, if you do some kind of changes to your data by updating the data, deleting the data, it will literally slow down your entire system's performance. Hence, It is, you are what, once you store the historical, it should not get changed. You're not supposed to change it. And time variant is store if you want to perform like for like analysis, like for like analysis. What is the sales in this quarter compared to last year, the same quarter? Year on year sales comparison, quarter on quarter sales comparison, week on week sales comparison. If you want to do it, so you need to store the data with time, right? So time based data, you need to store the data with time, date, time, and right. So these are the things you need to. So these are, this is how they define it. So data warehouse is nothing but it is having integrated data, historical data, and the data whatever we store, the historical data we store in data warehouse, it is a non-volatile. It should not get changed, and it should have time-based data in it. All right, that is what data warehouse is all about. And the next one is the data lake. Nowadays, if you talk to any analytics guy, right, data scientist or data analyst, they use this term more frequently. Most of the large customers, they use data lake. So if the customer is using Azure, they use Azure Data Lake. AWS, Amazon Web Service related cloud, those they use data lake there. And what is the difference between data warehouse and data lake? In the case of data lake, very simple. In the case of data warehouse, we perform ETL process. What is ETL? E stands for extract, T stands for transform, L stands for load. You extract the data from your source system, simply pull the data, and then you do the transformation into the staging area, and then you load the data into data warehouse. When it comes to data lake, what we do is you extract the data from your all the source system and then load it into your lake, data lake. Your data lake is the source. Okay, so this data lake will have all the source systems data in it, the raw data it will have in it. Once you have the raw data available in a centralized place called data lakes, that raw data you can use this raw data, and then you can do some kind of data transformation, and then you load it into data warehouse. Instead of using staging area, we are using, see, in this case the data lakes is something like a staging area, but it's a centralized location. Whether you are a data scientist or machine learning engineer or you are a data analyst, you go and pick up all the data from here, all the source system data here. Now the question is, first of all, why we need a staging area? Why we need a lake here? While I extract the data from the source system itself, can't I do T here, transform data? Extract, see here extract load, here also extract, and then you do T and then L. The T we do it in staging area, right? But here we don't do transformations. So while you extract the data from your source system, if you do the data transformation on the fly, what will happen is it will literally slow down your source system database. Your source system database is accessed by your customers, Amazon or Walmart. So every 1 hour, on an average 1 million transactions, or customers are keep ordering the product across the globe, 24/365, because different country have different time zones. Our night time is US daytime. During their daytime, they order it. During our daytime, we order the product. Across the 24/365, customers are keep ordering the product across the globe. This source system is accessed by people across the globe. This is mission critical. So on top of this, right, already many people are accessing, many customers are accessing across the globe your source system database. See, let's say you want to order water heater, or you want to buy some air conditioner, right? You go and search, do some kind of analysis. Which brand is cheaper and best? Which brand offers more features? Which brand they give deal? You do analysis, right? Everything you do. So for all those things, the data is stored here. It has to cater to each and every users based on the type of search they make it. Already this one is busy. On top, just because you want to do some kind of analytics, if you do data transformation by pulling 10 tables and you apply some group by and having clause when you use it, what will happen is that the transformation will happen on the source system itself. Already your source system database was clogged because of many people access the database across the globe. On top, if you stress your source system database by doing the data transformation for your analytical purpose, it will literally slow down the performance. The best practice is anything related to analytics is simply pull the data, read the data, and then load it into a lake. Okay, once your source system copy or duplicate of source system data available here, and then you apply, you have a dedicated place, and then you apply the data transformation, and then you load the clean data into data warehouse. Now you understood in real time how we pull the data. Okay, there are some exception to this. There are customers, they cannot afford to set up an expensive data warehouse. So in that case, also Power BI, supports like anything. Look here, in this case, look here, within this Power BI desktop itself, we can create the data model here. In Tableau or ClickSense, you cannot do the data model design here. So this is a dimensional model. Dimensional model is also called as your star schema or snowflake schema. Okay, when it comes to data warehouse, we use this term dimensional data model. Dimensional data model. Dimensional data model. Data model, which is nothing but either a star schema or a snowflake schema. Okay. So if you cannot afford to have a data warehouse, you can do all kind of dimensional data model design in your Power BI desktop itself, and then you can store the data in your Power BI desktop itself. Okay. And again, you have different options. We discussed about different types of storage modes. One is import, direct mode, and we have live connection. Right? So it doesn't mean all the data will get stored. Depends on the storage mode that you used it, the data will be available. Supposing you are pulling the data for this thing, right, using the using the direct connection mode, still the model is ready. It will simply go and fire the query on your source system SQL server and then get the result back to your Power BI desktop. Okay, so hope you understood the big picture. First, you understand. If you know only Power BI SQL query, that is not sufficient. Every ETL data analyst should be knowing what is data lake, what is data warehouse. Nowadays, the term data lake is very popular. Azure data lake, everything. By default, in Power BI, when you publish any report on the Power BI cloud service, it is getting stored in the Azure data lake only. So you don't have to learn cloud. You don't have to know how to store the data on Azure data lake. When you publish the report, it goes and gets stored in Azure data lake only. Okay, so now we will understand what exactly star schema and flow schema. See, I have taken a digression here because unless you know all the things, right, there is no point in talking about the data model design, everything, down the stream. Okay, first you understand what exactly star schema is all about, what exactly snowflake schema is all about. In the case of star schema, we do denormalization. It is also called as a dimensional data modeling. Both, okay, snowflake and star schema, dimensional data modeling. Why we call this star schema? You can see something like the fact table here, sales fact table. This is a transaction. It will have this transactional data, historical data in it. So all these Tables also have the historical data, but this is the one will hold huge volume of data in it. Okay, this fact table is a kind of a transaction table. Okay, and this fact table is surrounded by various dimension tables. These are all called your dimension tables. Since the fact table is surrounded by dimension tables, it looks like a star. Hence, we call it star schema. You just think that way. Okay, these dimension tables are also called as a lookup table. When you work with your customers, Americans or UK people, right? They use this term lookup table. Did you do a lookup? Which lookup table you used it? Don't get confused. Lookup tables are nothing but he's talking about dimension tables. It is also called a lookup table. The formal definition is dimension table. We don't say product table, product lookup table. Instead, we say dimensional, product dimension, category dimension, employee dimension, region dimension. Why do we call it a dimension? If you want to perform the analysis in multi-dimensional, you can do slicing and dicing with these dimensions. These dimension tables gives context to your data in the fact table. These dimensions give context or meaning to your data that are part of your fact table. So what do you mean by fact table in this case? The fact table will have facts in it. It will have the facts in it. What is fact? Facts are nothing but the numeric value. For example, you have a measure called, let's say you have something called the sales amount, and then you have gross sales, and then cost of goods sold, COGS, cost of goods sold, gross sales, and net margin. These are all the numerical variable, right? All the numerical variable, you just think that okay, the numerical variables are called your measures. Fact table will have the numerical measures. Along with this, it will have the dimension key, because you need to have the relationship between all these dimension tables with your fact table, isn't it? So in that case, you need to specify, for example, product dimension, product key, and product key and sales fact table. You need to link with this. So in order to link this table, you need to have the product key here. In order to link these two tables, you need to have the category key here. So category key, I just write a simple thing, cat key and EMP key, employee key, and date key, and region key. But here only key will be there. The key will have some numbers, right? So 100, 101, something like that, right? But let's say if you find in a specific record in this fact table, if you find something like 215 and 865, and if I ask you what is 215, what is 865? Okay, I have a column called quantity. This is a quantity. This is the sales amount. This is the quantity. This is the sales amount. But it doesn't make any sense, right? So 215, if somebody is asking you, okay, and hey, I can see something in the 1000th record. Under the quantity column, I can see 215. In sales, I can see 865. If they say something like this, it doesn't make any sense. That's the reason why the fact table is surrounded by dimension tables. With the dimension table, we can tell in North region, Q1, and product A in category A sold by so-and-so employee. Marketing guys, okay? So these dimension tables will hold the detailed information about product key, product name, and then the unit cost price, and then stock on hand, and effective start date, effective end date, something like that. Similarly, category key, category name, all the category related data, employer related data, product related data, date related data, region key, and then the region name, something like that. Okay, so those information will be there. So with this, the dimension tables gives context to your data. Now you know only 215 and 865. Since you store the key for all these dimension table, when you join these two tables, you will get to know, oh, this is North region in Q1 or month 1 or last week 1, sales of May month for product A in category C and sold by this employee. So with this dimension table, we are able to give context to the values that are stored in your fact table. This fact table, in this dimension table, you will have, I was talking about product key, category key. All these are called surrogate key. These are called your surrogate key. Primary key, instead of saying primary key, we call it surrogate key. Surrogate key is a unique value. Okay. So they use this different term. Okay. So surrogate key, each dimension table will have a surrogate key. Using the surrogate key, you can uniquely identify the records in each dimension table. Okay, fine. So next one is snowflake schema. Snowflake schema is also more or less same, but only difference is we, instead of storing the data in a single dimension table, in this case, what happened? The product data we split it and stored it into 3 different tables. We stored the subcategory separately and categories separately, products separately. Okay, so this is called snowflake schema because you are, doing normalization here. The idea of a snowflake is, right, it is just an extension of your star schema only, right? So here the tables are not directly linked to the fact table. See, the dimension category table is not directly linked to your fact table. Rather, your product table only linked with this one directly, right? Right. So, so if you have a scenario, right? So in this case, the dimension category table is indirectly connected to the fact table. So if you have a scenario like this, we call it as a snowflake. See, generally we do it because, we may not want to have a repeated rows. For example, in the product table, one product may have multiple suppliers. Okay. So I may not want to repeat the suppliers values in that table. So I want to keep it separate. Let's say I have another table called suppliers, dimension suppliers. We call them as vendors. Instead, other term is supplier. Okay, we have some supplier, something like that. Okay, so we store the supplier data for each product separately, right? So in this case, to know which product is supplied by which product to my business, so and which product was sold by which employee, that product supplied by which vendor, on which date, on which region, right? So all these data you can get it here. So in this case, for example, with this, I'm going to wrap up. Don't worry. Okay. So let's say in my product table, I have something called product key. I have a columns like product key and product name. Product name is there. And then I have the cost price. Cost price is available. And I have some other columns are available. Along with this, I have some categories there. Category. Let's take simply this example, category. Okay. In that case, what will happen is, let's say you have a product name is let's peanut butter. The cost price is let's $72.85, and category is let's this is falls under let's assume a dairy product, and you have something called vanilla ice cream, and this cost price something. This also falls under dairy, and you have some milk and butter, milk, buttermilk, right? So all these things falls under dairy category. So here, dairy, multiple time you are repeating it. For in a single dairy category, in the dairy category, you are selling close to 1,000 products like ice cream and milk, buttermilk, curd, and then what do you say? Yeah, so these are let's say 1,000 different products you are selling in this dairy category itself. So 1,000 times it will get stored, right? Instead of storing the dairy, right? So what you do is you just say some key value C001. It will consume less space. Some category name will be very big, right? Home appliances. Let's say your category name is home appliances. Instead of in home appliances, you sell, let's say 10,000, 12,000 products. In home appliances, you store 12,000 products. In the category column, For 12,000 records, if you specify home appliance, home appliance, home appliance, what will happen? It consumes too much of space. Instead, you say in a home appliance, some code, right? So dimension key, right? So for the key for, sorry, the category key is HA01. Instead of saying home appliances, HA01, HA01, you just store it. It will consume less space, right? So to redundantly, instead of storing the data redundantly, what we are doing is we are separating it. So you store only product related data. Category, you instead of category, right? Instead of putting home appliances, put HA01. And for this, if I want to know what is HA01, join this table with this table. In this table, I have the category name in detail. It is available for this category key. You need to do a lookup on the category table to get to know the category name, by joining these two tables, right? So you need to join these two tables based on the common key column, the category key and category key. But this table, you get the category name. That's why I use this term. When you do a lookup on this category table using the category key from product table, you will get the category name. Don't worry, I will show you with the example in Power BI desktop. Anyhow, as of now, I covered this much. I think I don't want to overwhelm you by talking, so many things in this session. I'm going to record this one. We'll share the recorded video and you watch it. And I would request you all to please watch all the videos, start from the first day to till date, before you come to the next week. And you can ask me doubts during the weekdays. Okay, don't hesitate. Okay, between 12:30 to 2:30, you can ask me questions. Okay, daytime. Okay, so what I'll do is I'll try to answer to your question same day if possible. And next weekend we will continue the part 1, part 2, and part 3 of data model. Okay, those are all very important concepts. Don't skip it. Okay, any questions so far? Any logistics, you can send a message, sir, the video I'm not able to access it, video problem is there, and voice quality is there. You send me, those are logistic related issues. You can send me a message so that we can create a win-win situation. Okay, and also that will help me to address the issues whenever I'm free during the weekdays. Okay, since you don't have any questions, I'm going to wrap up the session now. See you next weekend. Don't miss out the upcoming weekends. They're very, very important. Okay, guys. Next, probably in the 1 month time, 1 month time, right? We'll try to complete at least the 80% of the topics. Okay, and we'll prepare your profile also. Make sure that you are not going to miss any of the sessions henceforth. Please review, watch my video, practice it. Okay, fine. See you next weekend.